When a single technical role, like basic front-end design or localized script writing, can be largely automated by a single model, relying on an isolated skill set becomes a structural risk. To remain relevant, modern engineers have to operate across intersecting tracks, handling data processing, predictive modeling, and agentic orchestration simultaneously. This necessity for integrated expertise is the architectural basis for the PragyanAI Super 30 Fellowship. It is structured as a 2-year, 100-full-day offline ecosystem designed to build multi-track AI architects. Traditional short-term boot camps generally funnel passive theory into a single static job role. In contrast, the PragyanAI model uses 8 specific technical skills to drive a continuous feedback loop towards 7 different career tracks. These traditional models often fail because they isolate learning from deployment. You might learn the syntax of a language, but you rarely build a shipping product. The PragyanAI model addresses this by making execution a prerequisite for advancement. Every skill mastered must result in a deployable product. We are going to reverse engineer this 8-skill ecosystem chronologically to see how it manufactures engineers capable of building these products. Moving away from theory-heavy transcripts toward a multi-track product-building ecosystem is the most reliable way to navigate the shift into generative AI. The construction of the technical stack begins during the 3rd and 4th semesters of the student's degree. Before building intelligence, the system requires a bedrock of data processing. This phase starts with 10 days focused on Python, database connectivity, and data wrangling. Next is 8 days of data science, focusing on descriptive statistics, and 8 days dedicated to business intelligence and analytics. The logic is sequential. Engineering large language models or neural networks requires an existing mastery of probability, hypothesis testing, and database architecture. Between semesters, the program uses 5-day execution sprints. This is where the theoretical concepts are subjected to practical application and solidified into actual competence. The outputs are tangible. Students generate functional, interactive business dashboards using tools like Power BI, Tableau, and Metabase. This foundational phase alters the student's baseline. They transition from a coder memorizing syntax to an active data wrangler prepared for the complexities of machine intelligence. By semester 5, the curriculum moves from analyzing historical data to predicting future outcomes. This introduces the intelligence layer, 10 days of machine learning, integrating predictive modeling, regression, and clustering algorithms onto the data foundation. The stack expands with 12 days of deep learning and computer vision, introducing specific architectures like convolutional neural networks. This requires a significant leap into tensor mathematics and the construction of object detection architectures using PyTorch and TensorFlow. The required deliverables escalate accordingly. Students now move toward live application deployments, using frameworks like Streamlit to host their models. To prove practical capability here, the curriculum mandates the completion of functional vision AI demos, executing tasks such as pose estimation and medical imaging analysis. Mastering this intelligence layer bridges the gap between managing datasets and engineering systems that perceive and interpret visual reality. Semester 6 represents the apex of the 76-day technical stack. Here, the final layer locks into place, focusing on natural language processing, generative AI, and agentic AI. These blocks map to cutting-edge industry tools. Students implement vector embeddings, construct RAG architectures, and deploy multi-agent frameworks using Crew AI. This phase is where the curriculum diverges from traditional computer science. It is no longer about writing deterministic code, it is about steering probabilistic models. Passing this phase requires highly specialized deliverables, specifically the construction of live RAG pipelines and the fine-tuning of large language models for domain-specific tasks. This phase results in the engineering of multi-agent systems, applications capable of orchestrating complex, autonomous workflows without constant human intervention. These agentic skills enable students to build minimum viable products, like an AI healthcare assistant, where specialized nodes parse medical data and generate insights autonomously. Successfully navigating this agentic frontier is the threshold where a student officially upgrades to a next-generation AI product engineer. A curriculum is only effective if there is a mechanism to enforce its retention. This is the function of the PragyanAI delivery engine. The entire 76-day architecture is governed by continuous evaluation, hybrid mentorship, and automated code judging. The output of this enforcement is substantial, resulting in over 100 projects, 8 hackathons, and multiple deployed applications for every student. This creates the program's primary artifact, the digital employability passport. In the current job market, a live web portfolio demonstrating deployed apps and an active GitHub profile carry more weight than a standard academic transcript. Only after this technical stack is verified does the timeline introduce a 24-day final placement track. By layering data structures, aptitude, and mock interviews at the very end of the curriculum, the program ensures these skills are fresh for technical recruiters. Forcing relentless execution over passive theory guarantees that graduates possess public proof of their capabilities before they ever face an interview. This 100-day journey is a meticulously structured manufacturing process. Every element aligns with market demand. The 8 technical skills flow into a central execution core, branching into 7 distinct job tracks, from data scientist to prompt engineer. The uppermost pathways, generative and agentic AI, exclusively feed highest-tier roles, specifically product engineer and AI automation. The core philosophical goal of this ecosystem is clear. It is designed to produce active, autonomous product builders rather than passive students. Modern technology companies are hiring candidates who can demonstrate functional SaaS MVPs and workflow automation. They are prioritizing demonstrable skill over paper certifications. The PragyanAI Fellowship forces alignment with these market stakes through a pricing model that requires half the tuition only after successful placement, secured by a 3-year engagement. This engineered ecosystem provides a definitive solution to the current bottleneck in early career technology hiring. It takes a single-lane coder and meticulously upgrades them into a multi-track AI architect. By structuring its curriculum as a chronological, execution-heavy pipeline, PragyanAI systematically manufactures engineers capable of deploying the specific products that are currently defining the industry.